Hey, this is going to be a short video. I just want to share a small project I've been working on. One thing that recently caught my attention is this old computer. This is a TK85, it's a Brazilian clone of ZX81 with a little bit of upgrading. The original ZX81 had 2 kilobytes of RAM memory plus ROM for the operating system or for BASIC. This has 16 kilobytes of RAM, the Brazilian clone is a little bit larger. What caught my attention in this thing, however, is that it does not have any special video IC for video generation. What it does for video is only using a shift register to output 1 byte, 8 pixels at a time, and some clever logic around the processor that copies from text memory, reads the font, and places that shift register with a correct value. Then, of course, over the clock of the CPU, it will output that video and show it on a TV display. This guy uses RF modulation, but mostly today people replace the RF modulator, don't use the RF anymore, they just use CVBS signal, or basically polar NTSC video signals. What's curious about this guy is that most microcontrollers today actually have something akin to a shift register, which is the SPI port. And for the clever logic around the processor, we can use DMA. Another guy that's trending today is the RISC-V architecture. For that, and especially in that scenario, you have CH32V003, which is about 10 cents a unit, or you can get a development board, which like this one, for a couple dollars. It's fairly cheap. The programmer for this guy is a little bit more, about $4, the WCH Link E, or you can use a bootloader development, or you can use USB bootloaders actually that have been developed for the IC. This guy actually has 2 kilobytes of memory, RAM memory, and 16 kilobytes of flash. So you have plenty of space to write little programs here, and it's kind of comparable to the old computers 40 years ago. So I guess Olimex has created the RVPC, where they do VGA output on this very IC and PS2 keyboard input. I don't have a PS2 keyboard to try here, so I decided to try at least video output. Television video outputs fairly simple signals. You only need about minus 0.3 volt for syncing, and between 0 volt and 0.7 volts for black and white image. You just need the proper timings on the signal to get them to display something accurate. For that, all I need to generate here is these 3 resistors here, the 3 blue resistors. One of them is ground for a voltage divider, and the other 2 are sync signal and black or white image color. The black or white image comes from the SPI, and the sync signals comes from a time repeat WM output. With this, one thing that I can do here, let me just show you the video capture. Let me get the video capture working here. Is basically generate video output. Oh, cool. Olimex, the RVPC Olimex uses quarter VGA, I guess 320 by 240 output. And here I'm kind of mimicking the ZX81 video output. It's not a ZX81 emulator, it's just the font that's similar and the video resolution. It's 256 pixels wide by 192 pixels tall. Actually it gives you about 30 characters wide by 24 tall. So this is a very limited text mode. Actually, we can go higher resolution, but it's don't have enough memory for that. At this resolution, you already take about 40% of the memory just for the character codes of each character on the screen. The font itself is stored in Flash, so it does not take that much space, or you have more space there, you have more room in there. Actually, one thing I tried here, is actually the AD's active duration and BD's blanking duration, which is how much time I spend in every interrupt of the system, on every scan line here for updating the image code. The T is the period for a scan line, so I have about 3000 clock cycles per scan line, of which I use 800 during active scan lines and about 100 during blanking scan lines. So you have mostly 75%, 80% of CPU power left for your own user code. A sample user code I have here, let me just run it from start, is about running a Mandelbrot set, where I guess it was mandatory to try that. As you can see, it runs fairly slow. It already is low resolution here. This resolution is actually 4 pixels per character. It's not really a graphical mode, much like the ZX81 wasn't. But you can see it runs slow, but it's still way faster than the original code. Anyway, all of this code is on GitHub. The code is actually segmented in 2 parts. One of them generates the sync signals for CVBS. I have implemented I guess interleaved PAL mode and progressive PAL mode. Progressive PAL doesn't really matter that much. Most displays today will actually get that. You can change that code. One part actually does this interleaving for the NTSC or for the CVBS signal, and that calls a callback in your code, which will actually update a small buffer that contains 1 line of pixels for drawing. That line of pixels, however, when you return it, you can replace the pixels with whatever you want. You can point it somewhere else in memory. You can actually decide horizontal offset, shift offset by clock using timers. So you can create some, you may be able to create some interesting demo effects out there. I'll leave that to you though. Anything you do here, I hope this is useful for you. I hope this is fun. If you do something fun with it, let me know. Okay, let's see you again next time, maybe. Thanks for watching.